Hi Trojans, Mrs. Ratzberg here. So today we are talking about lesson 1.2 in stretching and shrinking, but we're going to start off with some vocabulary. So let's get started. So we're going to talk about two vocabulary words today in lesson 1.2, and those are corresponding sides and corresponding angles. And both of them actually have very similar definitions, just with sides or angles. So corresponding sides are sides that have the same relative position in similar figures. And corresponding angles are angles that have the same relative position in similar figures. Okay, so now let's see what the lesson's about and why we needed to know corresponding sides and corresponding angles. So I'm going to go down to page 3, lesson 1.2, scaling up and down. And our focus question today is, when you copy a figure at a certain size factor, how does this value affect the measurements of a new figure? And now you mean side lengths, angle measurements, things like that. Okay, so when you study similar figures, you often compare their sides and angles. To compare the parts correctly, mathematicians use the terms, and here are those words again, corresponding sides and corresponding angles. In every pair of similar figures, each side of one figure has a corresponding side in the other. Also, each angle has a corresponding angle. Okay, so let's now see what that really means in action. So here we see triangle ABC and similar triangle to that triangle DEF, excuse me. So first, I always like to identify the corresponding angles first, because from there, it's easier for me to find the corresponding side lengths. So I'm going to use a highlighter to kind of identify those corresponding angles. So I see an angle that looks an awful lot like a right angle, and that would be angle A and angle D. So those are our first corresponding angles that I'm going to write, angle A and angle D. So I'm going to pick a different color highlighter. Let's do orange. And then I see a slightly bigger angle, C, and that looks an awful lot like the same size as angle F. And so those are also corresponding angles. So in orange, angle C and angle F. And the convenient thing about a triangle, there are 3 angles, so that means the other 2 must be corresponding, B and E. So let me go ahead and write that in green, angle B and angle E. Okay, so now it's going to be a heck of a lot easier to identify those corresponding side lengths. So first off, we have from angle A to angle B, that side length, that's called AB. And then to go from the same pink to green would be D to E, or side length DE. So AB and DE are corresponding. Now you also could have said BA and ED are corresponding, but they have to go in the same order. I know that seems really like detail oriented, but it's going to come into play as you get into further levels of math. Okay, so now I'm just going to change colors here, so let's go with blue. And so now we also have corresponding angles from green to orange, or B to C, B to C, and then also then from green to orange on the bigger triangle, E to F, and EF. Okay, so now we just have that one angle left, so I'm going to pick, let's go red. Okay, so then I'm going to say, well, from orange to pink, that's definitely one, so FD. And then again, I have to go from orange to pink. I can't go pink to orange because that's technically not the same direction. That's not the same direction, so we have to be consistent. So then it would be CA. All right, so now you're going to try identifying your own down here. So I want you to pause the video and identify your corresponding angles and corresponding side lengths. Feel free to use as many colors as you need to. Okay, so now we're back, and I'm just going to write down the corresponding side lengths and then the corresponding angles. And remember, if both of your letters are the opposite the opposite order, then you're totally correct still. So we have FG and JK, JK, then GH and KL, and finally HF and LJ. So again, just as an example, if you had said FH and JL, that would have also been correct. Okay, so now corresponding angles, we have angle F and angle J, angle G, and angle K, and that's the angle symbol, that's like the less than symbol, and then angle H and angle L. So those are the corresponding sides and angles. And so now you're wondering, well, why do I have to do that? Why do I have to know that? And it's because when we compare similar figures, we need to be consistent and be very clear about what corresponds from one similar figure to the other one. And so we just need to make that very clear. Okay, so now what you're going to do, you're going to look at these three pictures. We have this original picture in the upper right-hand corner, right here, original. And Daphne thinks the rubber band method is clever, but she believes a school copier can make more accurate copies in a greater variety of sizes. She makes a copy of the house at 75%. Then she makes a copy with a setting of 150%. Use the picture above to answer the following questions when copied at 150%. And in parentheses, it says scale factor of blank. And they just want you to convert the scale factor from a percentage to a scale factor of a decimal. So 150% is the same thing as 1.5. Okay, so I want you to pause, and I want you to answer these following 4 questions about side lengths. So compare side lengths, compare angle measurements, compare perimeter. Remember, perimeter is when you add all the numbers together. And then also compare areas, and that's when you multiply your length times your width. So go ahead and pause and do that now. Okay, so you hopefully did all that now, and I'm just going to be very, very brief with my explanations. Hopefully you are in class watching this, and we will have further discussion to add more details. But some things to notice is that the side lengths did what? They got bigger. And an example of that, it went from like 8 to 12, right? Like if we look over here, let me see. So the original length here is 8, and then the new bottom of this house was 12, okay? And then describe how the angle measures compared. They stayed the same. And I'm not being as detailed in what I'm saying, but you are more than, I would love to have a lot of great detail here, okay? And next, describe how the perimeter of the large rectangle compares to the rectangle in the original figure. And so for that, the perimeter is larger. Perimeter is larger. And that went from 24 to 36. Wow, that was pretty big. And then again, the area got larger. Area is larger. And that was from 32 to 72. And even just giving those numbers adds more detail to support your answer. Okay, so then on the next page, you are going to see, you're going to do the same, answer the same questions, but instead it's going to be when you're copied at 75%. So go ahead and pause and do those questions now. Okay, so hopefully you answered those questions, and let's scroll down and see if you were pretty similar. So we have side lengths got smaller, then the angle measurements stayed the same, the perimeter got smaller, and then the area was also got smaller. But notice, I don't know if you took note of this, but the perimeter just went from 20 to 24. That's not nearly as much. Or sorry, 24 to 20, excuse me, because things got smaller. 24 to 20. That wasn't nearly as much as 24 to 36 difference. So I'm wondering if that has something to do with the size factor. This size factor was 75% of the original. And then the initial one we looked at was 150% bigger. So maybe how much further away it is from that 100% regular size, maybe it has something to do with it. I don't know. We'll keep looking, I guess. Okay, so now we have these two questions. How do the relationships in the size comparisons you made above relate to the copier size factors used? So what do you think? Let's think about what happened in the 150% house. What happened there? Well, if you said everything got bigger aside from angles, you are 100% correct. The house got bigger. But something to note, the angles stayed the same. Angles same. And then with our 75% copy of our house, what happened? Yeah, the house got smaller. Whoops, it would help if I spelled right. And again, angles remain the same. I don't know why I added an S over here. Okay, so part D, if two figures are similar, what is the same about the figures and what is different? So what did you notice? Go ahead. What did you notice stayed the same? Go ahead and brainstorm that either in your head or in class. Okay, you're right. So what stayed the same, or I hope you were right, the angles and then also the general shape. And then what was different were the length of the side lengths. Okay, so then finally, when you copy a figure at a certain size factor, how does this value affect the measurements of the new figure? So with our angle measurements, I have to write smaller because I have a lot to say. I might not be successful with that. With our angle measurements, they stay the same. And remember, anything I write, you should be writing. So anytime you need to go back and look again, that's fine. And then if we noticed, if our size factor is greater than 100%, side lengths grow, or side lengths get larger. And if our size factor is less than 100%, the side lengths get what? Yeah, smaller. All right, so then you will be completing the 1.2 practice and let your teacher know if you have any questions. Thanks so much. Bye-bye.